Dear children, let's continue the construction of quadrilaterals. What are the constructions? We have already done the construction of quadrilaterals when four sides and one diagonal are given. Second, three sides and two diagonals are given. The third, two adjacent sides and three angles of a quadrilateral are given. We have seen how we can construct the quadrilateral in these three cases. Now, another case is when three sides and two included angles are given. Construction of quadrilateral. Fourth case, when three sides and two included angles are given. Two included angles are given. Included angles are given. For example, construct quadrilateral ABCD. where AB 4 centimeters, BC 5 centimeters, CD 6.5 centimeters, angle B105 and angle C 80 degrees. What is the first step in the construction? Drawing a rough figure. So we can represent these measures by after drawing a rough figure. Quadrilateral ABCD, AB 4, BC 5, CD 6.5, angle B 105 degrees, angle C 80 degrees. 80 degrees. What do you understand by included angle? Included angle. By included angle we mean the angle made by the two sides of the quadrilateral whose measures are given. The measure of DC is not given. Measure of CB is also known. 5 and 6.5. In between, or they make the angle 80 degrees. Such an angle is called included angle. And consider this angle B 105. Is it an included angle? Yes. Why? Because AB is known, BC is known. But what about angle A? Angle A cannot be considered as an included angle because only the length of AB is known. AD is not known. So, included angle. The meaning of included angle is the angle made by the sides whose measures are given. Now we can construct this. 4 centimeter. AB 4 centimeter. Then BC 105. BC 105. How can we draw 105? 90 plus 50. So first 90, then plus 15. So draw arc like this. 60, first arc, 102. In between 60 and next 60, we can draw the arcs like this. Now we get 90 degree. Here this measures 90. So from 90 to here, from 90 to here, there are 30 degrees. So draw the bisector of this angle with a convenient radius. So what is the measure of this measure? Yes, this measure is 105 degrees. AB 4 centimeter. 105 degrees. Which is this point? This point is C. From C we require 80 degrees. 80 degrees. With the help of a protractor, we can draw mark 80 degrees from point 3. C. From point C. Mark 80 degrees. See. 0. Here 70, 80. This is the position of 80 from here. degree. Now 80 from C 80 degrees 6.5 centimeters long. 6.5. So draw 6.5. Measure 6.5 and draw an arc of 6.5 from C. 6.5. From C. This is the arc which represents 6.5. Then draw a line through the measure, through where we marked the 80 degrees. We can extend this. Then join, which is this point. This point is D. D. Then join AD. Join AD. So here angle C 80 degrees. ABCD is the required quadrilateral. ABCD is the required quadrilateral. So measure here 5 centimeter. 5 centimeter from here. You must take drawn the arc of 5 centimeter. 5 centimeter arc. 105 5 centimeter. Then from that point draw 80 degrees. What is the measure of DC? 6.5 centimeter. So ABCD is the required quadrilateral in which what are given? AB 4 centimeter, angle B 105, angle C 80 degrees, DC 6.5 centimeters. Now you can do the complete this and then do exercise 4.4 question 1, sub question 1 and 2. Next, some special cases of quadrilateral. Some special cases. What are the special cases of quadrilateral? So we got 3 cases in which we can construct a quadrilateral. How many measures are required to construct a quadrilateral? 5 measures. They are the 4 sides and 1 diagonal, 3 sides and 2 diagonals, then two adjacent sides and three angles. Then three sides and two included angles. These are the cases. Now, let us consider some special quadrilaterals. What are the special quadrilaterals? A square is a special quadrilateral. Why? All its sides are equal, all its angles are also equal. Then a rectangle is also a special quadrilateral. Opposite sides of it are equal, parallel and equal, and all the angles are equal. Rhombus, all the sides are equal, diagonals are perpendicular bisectors of each other. Such quadrilaterals are classified as special cases, special quadrilaterals. For example, because these quadrilaterals have certain properties. For example, in this case of a square has all the sides equal and all the angles are equal. Diagonals are also equal and diagonals bisect each other. Owing to these properties, we require only one measure to construct a square. To construct a triangle, we require three measures. For construct a quadrilateral, any quadrilateral, we require five measures. But for special cases, quadrilaterals which are considered as special cases, we require minimum number of measures to construct. That is, first one, some special cases. Square. Example. Construct a square ABCD. The square ABCD, whose diagonal is 5 centimeters. Whose diagonal is 5 centimeters. Only one measure is required. Diagonal. So the diagonals of a square are equal. Also, they are perpendicular bisectors of each other. So, how can we construct this? First, a rough figure. Diagonal 5. So, this diagonal also 5. So, now we can construct a square 5 centimeter ABCD. ABCD. AC 5 centimeter and diagonal. First we can draw diagonal AC 5 centimeter. Then draw its perpendicular bisector. How can we construct a perpendicular bisector? By taking more than half length, draw the arcs. Here this is the midpoint. So AC 5 centimeter. AB, this is the point. Sorry, we have to find the point B and C in such a way that the total length of the diagonal is 5. So the diagonals bisect each other. We have to measure upwards 2.5, downwards 2.5. Upwards 2.5, downwards also 2.5. So here this is the point B, this is the point D. Then join. ABCD is a square, 5 centimeter, 5, or we can write 2.5 centimeter, 2.5 centimeter. This will be perpendicular. 2.5 centimeter square. Now another example. Construct a square. Construct a square whose side is 4.5 centimeters. Side. All the sides are equal and all the angles are right angles. So we can construct it. First draw figure square 4.5 side PQRs. Let us name PQRs. So first we can draw 4.5. Then one side. Then how can we draw the next one side? It is next side is perpendicular to the first side. So draw a perpendicular. From here also. Draw perpendicular. This is the perpendicular at this point P, this point Q, this vertex Q. And now we require 4.5 on this. 4.5. How will you measure 4.5? Same length PQ. Take this length and from this part draw an arc. That cuts the perpendicular. And from this point also draw an arc. And from P also draw another arc. All the lengths are equal. This is the point R, 4.5 centimeters. This is the point S. This is square 4.5 centimeter. Required square PQRS. Second one, rhombus. Second case, rhombus. What are the properties of a rhombus? Rhombus. All the sides are equal and the diagonals are perpendicular bisectors of each other. Diagonals are perpendicular. Not diagonals are not equal, but they are perpendicular bisectors of each other. Now, for example, let us consider a rhombus. Consider rhombus ABC. Construct a rhombus ABCD with AC 6 centimeters and BD 7 centimeters. Diagonals are given and the diagonals are perpendicular bisectors of each other. So using that property we can draw this easily. So two measures are required. To construct a square we require only one measure. For a rhombus two measures are required. So if here the diagonals are given, if one side is given and one angle must also be given, then only we can construct a rhombus. So first draw a figure. Rhombus. All the sides are equal. It's a parallelogram with all sides equal. Here diagonal ABCD, AC 6, BD 7. That means 6, 3, 3, 3.5, 3.5 perpendicular. So first we can draw AC. AC 6 centimeters. AC 6 centimeters. Then draw a perpendicular bisector. Perpendicular bisector of this. here this perpendicular bisector. Now second diagonal, they bisect each other. So second diagonal length 7 centimeters. So 3.5 upwards and 3.5 downwards. So mark 3.5 upwards and 3.5 downwards. This is the point B. This is the point B. Join. This is rhombus ABCD. 3.5 rhombus. This is the required figure. Now the next is rectangle. Third special is rectangle. Rectangle. So in the case of rectangle also, the diagonals are equal and bisect each other, not perpendicular, bisect each other, and opposite sides are parallel and equal. So we can construct this. Construct a rectangle whose adjacent sides of length 4 centimeters and 5 centimeters. Adjacent sides. Construct a rectangle. The rectangle ABCD whose adjacent sides are 4 centimeters and 5 centimeters. 4 centimeters and 5 centimeters. Draw figure. Rectangle ABCD. 5 centimeter, 4 centimeter, or 4 centimeter, whatever it is. No. 5 centimeter. Now we can make use of the property the angle 90. All the angles are equal. So using this property we can draw this easily. First we can draw one side AB 4 centimeter. AB 4 centimeter. Then draw a perpendicular. Draw a perpendicular from B or A, whatever it is. Then along this side take a 5 centimeters length. 5 centimeter length. Which is this point C. 5 centimeter, 4 centimeter. Now take the same measure, same length, and draw an arc from A and draw an arc from C. What is this point? Point of intersection of the arcs will be D. Join AD, CD. AD and CD. So ABCD is the required rectangle. ABCD is the required rectangle. So when the diagonals of a rectangle are given, suppose we are given that length of the diagonals length of the diagonals. We can draw this. We can here we require how many measures are required to construct a square? 3 measures are required because since this rectangle. This is a rectangle, so its angle is 90 degrees. That is understood. That is why we are given 2 measures here. But we require 3 measures. At least 3 measures are required to construct a rectangle. So length of 2 diagonals are given. The angle between them also be given. Then only we can construct the rectangle. For square, or either one of the sides, length of the side or diagonal, because diagonals are equal and perpendicular bisectors of each other. Rhombus, we are given the length of the diagonals and the length of the diagonals. Their diagonals are perpendicular bisectors of each other, so we can construct it. And if one side is given, one side and one angle. One side and one angle of a rhombus are given, we can construct it. That is, to construct a square, we require 2 measures. 2 measures, either the length of the diagonals or one side and an angle. One side and adjacent angle. An angle with that vertex. Now, do the exercise 4.5 questions from 1 to 4. Thank you.